This video is about composition of functions. If you have seen the movie Inception, which I highly recommend, if you haven't seen it, you should go see it. But in Inception, the idea is that you can have a dream within a dream. Function composition or composition of functions is like the inception of functions. So you're basically going to end up with a function inside a function. So let's get started. So if function notation or composition notation works in a couple different ways. If we have h of x, a composition might be f of g of x. Or sometimes it looks like f, and then there's this symbol, it's a little circle. It's not a dot, it's not filled in like the multiplication, it's a little open circle of g, and then the x would be on the outside. And those are the same thing, they both mean composition. So this one, you would read it as f of g of x, and this would be the same thing, f of g of x. Okay? So when you have a composition of functions, it creates a new function. So we would have had to start with a function named f and a function named g, and then when we use composition, it would give us a new function which we could call h of x. So let's take an example. So say we have a function that looks like this, 6 over x squared. And then we also have g of x, which looks like 4x plus 5. If I want to find the composition, well, let's actually even further back than that. When we're talking about functions, we know that for function f, this means that we, for whatever is in here, we are going to square it, and then we're gonna put it under 6, right? And for g of x, whatever's in here, our rule tells us we're gonna multiply it by 4, and then we're gonna add 5 to it, okay? So if I ask you for this, f of g of x, what that means is that I want you to put this g of x function into the f of x equation as a replacement for x. So we would put the g of x expression in these pink parentheses right here, and we would perform the operations. So this ends up looking like, we'll do 6 over, and then the g of x is 4x plus 5, and then we're going to square that whole thing. Okay? So all we did is we took the expression for g of x and we put it where the x was in the f of x function, and we could either leave it like that or we can expand it. And if we expand it, we know that we have to FOIL the bottom there. So we would get 16x squared plus 40x plus 25. So this expression here is the composition of those two functions. All right, let's look at another way to combine them. If we have g of f of x, we're going to do the same thing, but now we're going to use the expression for f of x in the function for g. So the expression for f of x was 6 divided by x squared. So our result is that we would have 4, but then we're going to plug in the 6 divided by x squared. and add 5. So all we did is wherever there was an x, we replaced that x with the f of x function. Cool? So this f of x function was here. Okay? All right, and again, here we would multiply this out, we would expand it, and you would get 24 over x squared plus 5. Okay? Notice, those are different. So the order in which you do composition matters, so pay attention to that. You can also use composition, you can do an inception of yourself. You can use composition on the same function. So in this example, if we ask for the composition g of g of x, that means that we're going to put the g of x expression into g of x. So we would have 4, and then we're going to put in 4x plus 5, because that's the g of x expression, plus 5. Cool? So we put the g of x expression into g of x. And again, we can expand that just by distributing and multiplying, and we would get 16x plus 25. Cool. All right, let's do a couple other examples. In this example, f of x is 3x minus 8, and g of x is equal to 2x squared. So here, I want g of f of 5. So what that means is that I need to first figure out what is f of 5. Okay, so f of 5 in this case is going to be 3 times 5 minus 8. So 15 minus 8, or 7. Okay, then we take this information, because this is f of 5. This was f of 5, this was f of 5, and now we plug it into the function g. So g says we're going to take 2, and we're going to multiply whatever x is, and then we're going to square it. Well, in this case, it's 7 squared, so that was our f of 5 still. And now we just do this math. So 7 squared is 49 times 2 is going to equal 98. So g of f of 5 equals 98. Cool? So we took 5, we plugged it into the function f. The result of that, we plugged into the function g, and we got this outcome. All right, let's look at our example B. So let's do f of g of 5. Take a second and see if you can figure it out on your own. Okay, so we wanted f of g of 5. So over here we found g of 5 by plugging 5 into the function, and we got 50. That was the result of g of 5, so we then plugged that result into our f of x function. And when you plug in 50 to the f of x function, you get 142. Cool. Let's look at another way to solve this. So we'll do f of 5. And in this case, what I'm going to do is I'm going to write an equation first and then sub in 5. Because in these previous examples, I found the value of 5 in the first function, and then the result of that I plugged into the second function. Now, in our very first examples, we were just writing new functions, right? So we could take these two functions, and we could write a new example or a new function. So we want f of 5, so we're substituting f into itself. So that would be 3x minus 8, and if I distribute, I get 9x minus 24 minus 8, which is 9x minus 32. Okay, so this expression represents f of x. Now, if we want f of 5, we can now just plug 5 into this expression. So we would have 9 times 5 minus 32, which is going to be 45 minus 32, which is going to be 13. And we could have done that either way. So we could have plugged the 5 into f, which we actually already had done. We knew it was 7. And then we could take 7 and plug that back into here. And if we do that, we would have 21 minus 8, which is still 13. So either way you solve it would be fine, okay? Let's look, let's do one more. G of 5. So let's think about this. Do we already know what g of 5 is? Yes, we do. It was over here. We already found it. So if we recall, our g function is 2x squared. So this would be 2x squared, right? Which ends up being 2 times 4x to the 4th. And then we could plug in 7 there to figure out what it is. But we already know what g of 5 is. Like, we already know that g of 5 equals 50. So if we plug in 50, we would have 2 times 50 squared. So 2 times 2,500, which equals 5,000. Okay, so just to sum up, the composition of a function is like inception. It basically just means that you're plugging a function into another function. So back in our first example here, where we had f of g of x, whatever g of x was what replaced x in our function. When we talked about figuring it out with values, again, so first we had to figure out what the value of f of 5 was. And once we had that result, we used that result and plugged it into the g function and found our answers. Okay, that's it. Thanks.